and gentlemen, today we are looking at constant rate of change. Constant rate of change is the idea of identifying when there's a change happening, what is the constant, obviously that's where it gets its name, rate at which it changes. So finding a pattern. Again, this is math, it's all about patterns. So right now you should be in your book on page 65. If you aren't there yet, pause the video, get your book out, be on page 65, ready to look at constant rate of change. So let's go to the vocabulary startup. Let's begin by looking at that. And you can see that it says a rate of change is a rate that describes how one quantity changes in relation with another. So a great example of rate of change would be when you earn money for doing a job. You work 1 hour, you earn $8. You work 2 hours, $16. 3 hours, $24. You can bring all that back to a rate of change, which is $8 per hour. So that's the idea. Let's take a look at the real world link. So a computer programmer charges customers per line of code. Fill in the blanks with the amounts of change between consecutive numbers. So you were supposed to look at this last night. Let me pause for a minute in case you didn't have a chance to look at it. Go ahead, pause the video, fill in those numbers, and then turn it back on. So when we look at how this is changing, we can see that lines of code from 50 to 100 was a change of 50. From 100 to 150, also a change of 50. From 150 to 200, also a change of 50. From 1,000 to 2,000, that's the cost, that was $1,000. From 2,000 to 3,000, another $1,000. From 3,000 to 4,000, another $1,000. So here's what we know. We're going to look at this, and we're being asked to label now. Change in lines, change in dollars, rate of change. So we know the change in dollars came right here. So this was the change in money, and this was the change in lines. We saw that every $1,000 was the change when you had a 50 line change. So we can simplify this. We can ask ourselves what goes into 1,000 and into 50, and that would be divide by 50. So we're dividing both these by 50, and we get down to $20 a line. So the change that happens that is consistent, the constant rate of change is $20 per line of code. So a customer, the great thing for a customer is they know if the programmer comes back and says, hey, I'm going to have to write another 5,000 lines of code, okay, I know what it's going to cost me. Or if they say I'm going to write another 20 lines of code, they know what it's going to cost because there's a consistent rate of $20 per line. Okay, pause the video if you need to finish those notes and then turn to the next. So one of the best ways to identify constant rate of change is through the use of tables. We saw that in the last line with the computer programming, and we're going to see it here in example 1. So example 1 is a fundraiser by washing cars. Number of cars washed, amount of money earned. Change of 5 in the cars washed, change of 40. Change of 5 in the cars washed, change of 40. Change of 5s in the car wash, change of 40. So we know that when you change the cars by 5, you change the dollars by 40. If we were graphing this, just a quick note, if this was being graphed, this would be the X and this would be the Y, because the number of cars you wash controls the money. The money doesn't control the cars. So we can simplify this, and again, we look for, is there a number that goes into 5 and to 40? You bet, 5 goes into both. So we divide both those by 5, and we get a constant rate of change of $8 per car. $8 per car washed. All right, try this got it problem. Pause the video. You've got two different rate of change problems here. Go ahead, work those out, and then start the video back up. Okay, let's see how you did with A, and then my suggestion would be, if you did A and you got it right, look at your work on B. Let the video play through. If you did A and you had a mistake, pause the video again and rework your B based on figuring out your mistake from A. So time and distance, which controls which? Well, time, the amount of time you travel, controls how far you go. The distance doesn't really control the time. So we're going to look at the change that's taking place. Here there's a change of 30 minutes. Here there's a change of 290. If you take 580 and subtract 290, you get 290. Here's another change of 30 minutes, and here's another change of 290. Here's another change of 30 minutes, and another change of 290. So what we see is the distance changes by 290 for every time change of 30 minutes. So we would look at that and we'd ask ourselves, all right, is there a number that goes in to both 290 and 30? Let's make the easy thing first. Let's say divide them both by 10. So divide 290 by 10, you get 29. Divide 30 by 10, you get 3. 3 doesn't go into 29 evenly, but 3 would go into 30 evenly. So we can say that the change in distance is about, because it's not exact, about 10 miles per minute. If you did 3 minutes into 29 miles, you're about 10 miles per minute. All right, if you had 10 miles per minute, go ahead and watch B. If you didn't have 10 miles per minute, pause the video and rework B. Look at the work you did and see how you can fix it. Okay, let's take a look at B. So again, the number of buses and the number of students. The number of buses tell you how many students you can carry. So we're going to look first at the change in the buses. So when the buses change by one bus, the students change by 72 students. You go up one more bus, and 288 minus 216 is 72 students. Go up one more bus, changes by 72 students. So when we look at the change in students based on how many buses, we get a change of 72 students per bus. If you think back, one of the things that happens with students is they think that there's all these new math concepts. Every day I come in, they teach us something new. In reality, these all go back to a constant, we're doing constant rate of change, that's kind of funny. They go back to a constant growth in the concepts. So if you think back to unit rates, if you took 144 and you divided it by 2 to get to a unit rate, you'd get to 72 to 1. If you took 216 and divided it by 3 buses, you'd get a unit rate of 72 to 1. If you took the 360 and divided it by 5, what do you think? Yes, no shock there. You'd get a unit rate of 72 to 1. So we're not learning brand new things. We're learning different ways of looking at the same idea. Everything we're looking at in this group of concepts all deals with change, and it all deals with being able to compare rates of change. And unit rate is the way that we do that. Okay, go ahead and pause the video, finish any notes on page 66, and then turn to page 67. A second way to look at a constant rate of change is by looking at a graph and seeing how the points on the graph change. Remember, we've talked about coordinate graphing. So let's take a look at example 2. Here's a graph that represents the distance traveled while driving on a highway. Find the constant rate of change. So first off, this 0, 0 point, that makes sense. If you're not spending any time driving, you're not traveling any distance. And then you'll notice the next point is 160. Spend 1 hour traveling, go 60 miles. Spend 2 hours traveling, go 120 miles. Spend 3 hours traveling, go 180 miles. So as we look at those points, and by the way, this is a proportional relationship. Points make a straight line, goes through the origin. So as we look at that change, we see for every 1 hour change, there's a 60-mile change. So we can say that our constant rate of change right here, 60 miles an hour. Now, it's important also to be able to look at any one of those points and identify what that point represents. So the 0, 0 point, I'm down into part 3 now, which goes with the same graph. The 0, 0 point represents you drive no time, you travel no distance. The 160 point, you travel 1 hour, you go 60 miles. Go ahead, I'm going to stop for a minute. Think to yourself, what do the 2 120 and the 3 180 points represent? All right, you should have looked at that and said, oh, this 2 120 point right here, that represents 2 hours driving and you traveled 120 miles. The 3 180 point, you traveled for 3 hours and you went 180 miles. So here's a got it problem for you. Go ahead, pause the video. It's got 2 parts, C and D. Solve those, then turn the video back on and we'll discuss the answer. All right, let's look at the got it problem. We'll start with the graph. Use the graph to find out the constant rate of change. So again, 0, 0, that makes sense. I travel for an hour, I go 30 miles. I travel for 2 hours, I go 60 miles. I travel for 3 hours, I go 90 miles. This is changing by 1 each time. I'm going up 1 more hour. Between here and here, that was 1 hour. Between here, where my next point is, the 3, and here, that was 1 hour. On this side, I went up, and by the way, that's also the 0 to the 1. Here, I went 30 miles. Here, I went another 30 miles. Here, I went another 30 miles. So every change of 1 hour brought me a change of 30 miles. Remember, this is all, by the way, again, we're doing speed here, which we talked about earlier, distance over time. Here, the distance over time was 30 miles each hour. So I'm traveling 30 miles per hour. And get in the habit, if you didn't write this out in words, write it out now. Get in the habit of writing out your words because, again, math is all about communication. Yes, it's about getting answers to math problems, but it's also about communication. Then what does the 0, 0 represent and what does the 130 represent? If you didn't do that now, pause the video for a moment, write that down. So the 0, 0 is no miles traveled in no time. Basically, you didn't drive at all, you didn't get anywhere. And the 130 is 30 miles traveled in 1 hour. All right, I think we are ready to move on. So if there's any note-taking you need to finish here on page 67, do that now, and then flip to the next page. All right, we're on the next page in example 4. So an important skill to have is being able to compare different things. And this is a life skill. You're going to travel through life, and you're going to be given different things to purchase, different opportunities, and you have to figure out which one makes the most sense. So that's what example 4 does. Example 4 gives us 2 different places that you could rent a bicycle. So you're traveling somewhere, and you decide to take a day, and you're going to rent a bike and go around the area. And you have 2 places you can go. You can go to pedal rentals. You can go to Supercycles. The question is, which one is going to be the best deal for you? So pedal rentals, you've got their information in a table. And you can see that every 1 hour change is $12. So pedal rentals is charging you $12 per hour. Now, when you go to Supercycles and you say, what does it cost me to rent for an hour? It cost me $8. What's it cost me to rent for 2 hours? It cost me $16. So this is $8 per hour at Supercycles. So pedal rentals charges more. You should only go there if they have a lot better quality bikes or if they throw in something extra. If everything else is the same, all the bikes are the same, you should go to Supercycles because you're going to save money. Okay, we're ready to practice some. Would you go down to the first guided practice problem and pause the video, work through that problem. You've got a table and a graph. It shows how much money Mi Ling makes and how much money Daniel makes. It's how much money they save. And the question for you is, use those pieces of information, the table for Mi Ling, the graph for Daniel, figure out who saves the most money per week. That's what we're looking at. The question we have is who saves the most money per week, and then explain how you knew that. So let's look at our tables. For Mi Ling, when you go from 2 weeks of savings to 3 weeks of savings, it increases by $15. When you go from 3 weeks of savings to 4 weeks of savings, it increases by $15. So we can say that Mi Ling saves $15 per week. Of course, it would be great if I could spell the word week. There you go. All right, now let's look at Daniel's savings. So here's Daniel for a week, and he saved $10. Here's Daniel for 2 weeks, $20. Here's Daniel for 3 weeks, $30. So for Daniel, when it changes by a week from 1 to 2, it changes by $10. It changes by another week from 2 to 3, it changes by $10. So Daniel saves $10 per week. So Mi Ling is the better saver. Now the second part of this was, what does the 0, 0 on the graph refer to, and what does the 110? Well, the 0, 0 is before Daniel starts saving, if he's been saving for 0 weeks, he has $0. So 0 weeks savings, 0 weeks saving money equals, I wanted to say $0 saved, equals $0 saved. All right, and how about the 1 and the 10? Well, 1 week of savings equals $10. And we know that every week Daniel saves, he's going to be saving $10. Okay, it's time for you to do some practice problems. So follow the instructions on how to begin that practice. And again, remember, the power of the videos is if you have any questions, you can always go back and review it. Thanks for listening. And if you have questions for me specifically, don't hesitate to ask.